Hello students, this video number 3 brings you some solution of numerical problems on simple stress and strain. Till now we have learned that stress sigma is equal to P by A, load by area, strain small e is equal to dl by L, and modulus of elasticity, that is capital E, is equal to stress by strain, that is sigma by small e. So these two or three relationships combined together make a big or very important relationship between change in length, load, length, area of cross section, Young's modulus, and this big formula will be derived, and then it will help in solving some problems. We'll see in this video. So I once again tell you, if you have any doubt, ask me in comment. Now consider a bar of steel with cross-section area A and length L is subjected to a load P. Then the change in length will be dl as shown below. See, if this is the steel bar whose area of cross-section is A, whose length is equal to L, if it is subjected to a load P, which can be tensile or compressive. This is tensile load, this is compressive load. So if the load is, suppose it is tensile, then what happens? The length increases by dl. At the same time, the diameter, which is this much initially, has been reduced. So diameter is reduced, but the length is increased. Similarly, if the load is compressive instead of tensile, the compressive load will be inward. If the load is compressive, the length decreases by same amount dl. Here also the diameter, the initial diameter is increased. In the first case, if the length increases, the diameter decreases. In the second case, in case of compression, the length decreases but the diameter increases. So this is tensile load, this is compressive load. Such a member which is under tension, which has been elongated, will be called tie, T-I-E, tie. And a member which is under compressive stress or compressive load will be called strut. Strut. Okay. Now we have dl as a contraction or elongation. Now suppose load is equal to P, area is equal to A, length is L, elasticity modulus is E, then stress, as we know, sigma is equal to P by A. P divided by area will give you stress. Similarly, we can find strain, which is small e, that is dl by L. So dl by original length, we can find strain. Also, from Young's modulus, we have found that E is equal to stress by strain. So in place of stress, we can write P by A, and in place of small e, we can write inverted dl by L को L by dl लिखिए. Okay. Now, if we want to find dl here, so dl will be PL by AE. This becomes a very important formula which will be helping you to find change in length or deformation if the load, the length, original cross-section area, and modulus of elasticity will be given, we can find dl. Okay. Now with this formula, using this formula, we'll try to solve some numerical problems. How to use this formula to find the change in length? We'll see it. Let us solve one problem. Some numerical problems. Our first question is, a steel bar of diameter 30 mm, length 200 mm is subjected to a tensile load of 150 kilonewton. Find the elongation of the bar if the modulus of elasticity of the steel is 2 into 10 power 5 Newton per mm square. If this is the question, generally such question comes in the examination. So how to solve it? Solution will be, always first make the list of the data given. Read the question thoroughly and extract the data. Make a data list. So in the question load is given. So you can write P is equal to 150 kilonewton. Length is given. L is equal to 200 mm. E 2 into 10 power 5. This much is given. Also diameter is given 30 mm. So using diameter we can find area, which is pi by 4 d square. We can solve it, find it here, but it is better to keep it like that so that you can use in the final formula. Now according to the formula, elongation is dl is equal to pl by a. Write the formula first. So pl by a, substituting the values of p, l, a and e, we can write here. For p we can write 150. See here, e is equal to Newton per mm square and p is in kilonewton. So it is better to convert this into Newton. So all the loads will be newtons, all the lengths will be in linear dimension will be in millimeters. So 150 into 10 power 3 is Newton load. This is length. Now pi by 4, this area pi by 4. So pi by 4 has come here. Pi by 4 d square and e. So solving it, we find 0.21 millimeter is the change in length. So this way we can solve the questions of simple stress and strain. We can find dl. So we'll see one more question. Using the same formula we can try another question. Question number 2. A steel rod of diameter 25 millimeter and length 180 mm is elongated by 0.25 mm under a tensile load. Determine the stress, strain and the magnitude of load. Take E 2 into 10 power 5 Newton per mm square. So here similarly, here dl is given 0.25 but load is absent. In our previous question P was given, dl was asked. Here dl is given, load is required. So what to do is, always make it a practice of writing the given data first. Read the question thoroughly and extract the data list. Given data. From the question, collect the data. L 180, DL 0.25, ES 2 into 10 power 5. Diameter is given 25, so area we use in the formula area only. We don't use D. So from the diameter we can find the area first. Either you can calculate the area or you can keep it like this, because this pi by 4 25 square can be directly put into the formula. Now with this data, one by one our requirement is stress, strain and load. Let us, with the given data, we see that strain can be easily achievable. Strain is small e, which is dl by L, both are present here. dl is there, L is there. So this is dl and L are present. We can directly find E is equal to dl by EL 0.25 by 180. So this is the value of strain. The second unknown question was stress sigma. Sigma, we know sigma is equal to E into E. Small e, strain into Young's modulus or modulus of elasticity. Now that we have found small e and E is given, so multiplying this you can find stress in one line. The last question was to find P. So now because stress is already obtained, so multiply area. Area is this one. If you multiply this stress into this one area, you will get the answer. So this is the load in Newton. We can present this load generally such a large value of Newton. We can make it kilonewton by dividing 1000. So this is the answer.